All right, so what we're going to be talking about today, since last time we talked about surface area for prisms and cylinders, we're not going to step away from those shapes. So what we're working with today is the exact same shapes that we worked with last time. Okay, so realistically, nothing as far as what we're looking at is going to change. However, one of the things that we're going to measure this time is a little bit different, because last time we talked about, for example, if I have this cylinder here, this can, right, we talked about, okay, well, how much metal would it take to make up this entire can? So we talked about surface area. All right, there's another type of measurement that's in here, and that's how much liquid does this thing hold? Okay, so there's two very different ideas and found very different ways. So what we're talking about today, right, is volume. And volume is that same idea with how much water can this thing hold, okay, or how much liquid can this thing hold, okay? So again, surface area is, how much metal it would take to make this. Volume is how much liquid would go into this, okay? So, and hopefully you guys volume should not be a brand new idea for you guys. Hopefully you've worked with it in like your science classes and so on and so forth. So you've at least heard the terminology before and everything. But we're going to figure out how to find it, right, for prisms and cylinders, okay? So the way that we're going to think about this and kind of come up with like a formula for it. So here I'm going to just kind of recreate my, with as great a drawing as I can do, I'm going to recreate my prism. Oh my goodness, Mr. Kiefer is the worst artist ever. Hang on. Oh boy. Okay. So here's my prism. So here's kind of the idea behind how this works. So let's just say I take this can here. I just take this sheet of paper. Do you guys know what a cross section is? No? Okay, so let me this is going to kind of explain. So if I take a cross section of this, so I'm going to take this piece of paper, this plane, and I'm just going to slice it perfectly through like either the center or just anywhere on here, like at a very perpendicular spot. When I do that, what shape do you think will be left on this paper? Imagine, if you will, how many of you have ever like had a cold drink and you set it on a table, and when you lift it up, there's like a ring. That's a cross section, okay? So if I put this can on top of this sheet of paper, right, and lift it up, what's going to be left, right, is a circle, right? Now, I can't find the area of all the volume and stuff like that in here, but I can find the area of this circle, okay? So if you think about it, if I take this piece of paper and I slice it, no matter where I slice it in here, provided this can is actually like, an actual prism and these parts aren't all wonky and stuff like that. But if I just keep slicing this thing, at every single point, I'm going to have the exact same circle, right? It's never going to change. Again, I'm not coming in and cutting it like this because that doesn't really make sense. But if I come in and I cut it like this, at every given point, I'm creating essentially another circle that's the exact same as the top and bottom. So if I imagine slicing this prism here, what shape do you think will be left on that plane? If I slice this pentagonal prism, what shape do you think will be left on that plane? Anyone? It'll be a pentagon, right? Because if I slice this thing, right, it's going to hit here, hit here, hit here, hit here, and hit here. Okay? So essentially what I've created on this plane here is, since we already know that the top and bottom bases are congruent, what we've actually done is create yet another congruent polygon. Okay? It's congruent to the exact same base. Okay? So no matter where this plane is that I slice it, oops. So no matter where this plane is that I slice it, right, I'm going to essentially have that same pentagon. So I'm going to have the exact same area as my bases. Okay? So now imagine if I just did this a million times, or an infinite amount of times. If I just kept slicing this thing, is there going to be essentially a maximum amount of slices I can have in here? Yeah, there is. What's the maximum amount I can have? What? You don't know? But you know that I can't just, because if I literally just kept slicing in here, right, eventually, like, think about water. If I just keep pouring water into this thing, eventually it's going to overflow, right? So what's the max amount of water that can essentially fit in here? That's the amount of slices I can have in here. It's the height. I can't fill this thing up past the height, right? So once I reach that height, I can slice as many times in here I want, right? And if they're infinitely thin, right, the maximum amount I can still slice in here no matter what is how tall this object is. So if I take each of those pieces, right, and I multiply them by the height, because I can have a total of height number of slices, that'll give me a good picture of what the actual volume is. Okay? And that's kind of where this formula really comes from. Okay? So volume for this, right? So if this is my height, right? My volume is going to be simply just my base area times the height. Because essentially we have a height number of slices in there. And I can't fit more than that. And if I only did like half this thing, that wouldn't really do anything. That wouldn't give me an actual volume. Right? It's not what's asking about for what the total thing I can hold is. Okay? So let's kind of apply that to this pentagonal or this triangular prism. So if I slice this thing, okay, what I'm going to get, if I slice this thing at any given point, I'm going to end up with another right triangle, right? And this thing's going to have the exact same area as the top. So even though this shape, right, isn't a regular polygon, this is still going to work, even though we have like an awkward prism where the top is not regular. Okay? But it's still a triangle. I can still find the base area of that. Okay? So for volume, right, we know that it's equal to the base area times the height. Well, what's the base area of this thing? Heck, we already found it when we were looking at surface area. We already know what the base area of this is. What is it? It's 6, right? It's 6. And then what's the height of this object? 10. So since the height is 10 and the base is 6, all right, my total volume is going to equal 6 times 10, which is equal to 60 units cubed. Okay? So when we did surface area, we did units squared. And here's kind of the best way to think about it and why we call it squared and cubed. Okay? When it's a square, or when we're doing surface area, we're essentially counting the number of unit squares that can fit into this flat plane. Okay? But now if I make this a three-dimensional object such as this, what we're really figuring out is how many little cubes I can fit in here. How many little one by one by one cubes I can fit into this thing. So that's why when we're doing volume and we're finding a three-dimensional measurement, we use cubes. When we're finding area, surface area of a two-dimensional object, we used squared. Does that make sense? Because we're finding the little squares versus finding the amount of cubes. Okay. All right. And that's how we can find volume of a prism. It's actually going to be a lot easier for cylinders, much like surface area is easier for cylinders. Volume is going to be even easier for cylinders. Okay. So volume, again, remember prisms and cylinders are essentially the exact same thing. Okay. However, for volume, right, if I'm looking at this, this right cylinder, again, if I take the cross section, I'm still going to get another circle that has the exact same radius and area, right, of my bases. Okay. So again, we're still going to use the exact same formula, base times height, because really the same ideas, the concept is still going to be there. Okay? But we know how to calculate the base area for any circle, right? What is it? It's the area of any circle. Pi r squared. You guys are so good. You got it. Great job. All right, yes, it's pi r squared, guys. The area of any circle is pi r squared. Okay? So since our h is, we don't necessarily know what it is in this case, right? We can generalize the formula for the volume of a cylinder as volume is equal to pi r squared h. Okay? I actually saw this really funny a post the other day. This is just kind of I guess I'll show this anyway. So if you think about a circle or something like this, and let's just say the height is a. Let's just say the radius is z. Okay, then the volume of this thing is equal to pi z squared times a. Well, if you're writing pi as in like the actual word, it's not PIE, it's pi times z, and then z squared is z times a. You can get I just thought that was funny. I just enjoyed that. But that's another way that you can kind of think about for volume. Sorry, I know that was a super lame math joke, but I just told it anyway. Okay? So that might be a way to help you actually remember how to find the volume. Pi r squared times h, or pizza. Okay? So for this right cylinder, right, since the volume, again, is going to equal base area times height, or more specifically, pi r squared h. The key pieces that we need are r and h. Right? Well, what's the radius of the base in this case? What's the radius? It's 2. Okay. What's the height? 4. Okay. So now all I have to do in order to find the volume of this is go pi times 2 squared times 4. Well, 2 squared is 4. Pi times 4, which is equal to 16 pi units cubed. Okay? Does that make sense? The volume is pretty simple. Okay? Now please remember though, the hardest part about all of this, at least for cylinders, it's no big deal. But remember, for prisms, you need to find the base area, and that's the hardest part. Okay? That's by far the hardest part. That's why we learn how to find the area of regular polygons and the area of different types of shapes, because that is the hardest part for finding the surface area of prisms. Okay? All right. Are there any questions on this? Okay, I'm going to stop the video, and you guys are going to have the rest of the period to work on the assignment for today. Okay? and I will be posting this video shortly.